Let us factorize the expression a to the power 5 plus a to the power 4 plus 1. We rewrite this expression as x to the power 5 plus x to the power 4 plus 1. We have just changed the variable from a to x because we prefer x as the unknown variable. Nothing great about it. Now you see that if x minus 1 is a factor of this expression, then if I write x equal to 1 here, then I should get 0. That doesn't happen. If x equal to 2 is a factor, then again we should get 0. You see that neither is it that x equal to 1, minus 2, minus 3 satisfy the expression equal to 0. So we see we don't find it, but if you know the complex number, you see that if I write x equal to omega, if I take x equal to omega, comma x to the power 5 plus x to the power 4 plus 1 equal to omega to the power 5 plus omega to the power 4 plus 1, where omega cube equal to 1 and 1 plus omega square equal to 0. Since omega cube equal to 1, omega to the power 5 can be written as omega square into omega cube, that's 1. Omega to the power 4 can be written as omega cube into omega. Okay, omega to the power 5 can be written as omega cube into omega square. And omega cube is 1, so this is simply equal to omega square plus omega plus 1, and that's 0 by this expression. Therefore, x minus omega is a factor of this expression. X minus omega. So far so good. X minus omega is a factor of x to the power 5 plus x to the power 4 plus 1 in the set of complex number. What about other factors? You see that if x equal to omega square, then x to the power 5 plus x to the power 4 plus 1 equal to omega square to the power 5 plus omega square to the power 4 plus 1. And that's equal to omega to the power 10, that can be written as omega cube whole thing cube, omega 9 to the power 9 into omega. Again, omega to the power 8 can be written as omega cube whole thing square, that's omega to the power 6 into omega square plus 1 as it is. Once again, omega cube equal to 1, so this expression can be simply written as 1 into omega square plus 1. But by second expression, 1 plus omega square is 0, so this is equal to 0. Therefore, again, x minus omega is. So we see that x minus omega is a factor of this expression, and x minus omega square is also a factor of the same expression. So we can combine that and say that x minus omega, because we would like to deal only in the set of real number, x minus omega into x minus omega square must be a factor, is a factor. So we see that x minus omega into x minus omega square is a factor of x to the power 5 plus x to the power 4 plus 1. Now, as we said earlier, we would like to restrict ourselves to the set of real number. Let's multiply this. Can we do it? Let's see. X minus omega into x minus omega square equal to x into x is x square, x into omega square as it is, minus omega into x minus omega x, omega into omega square, that's omega cube. Once again, x square as it is. Take minus x common, you get omega plus omega square, and omega cube is 1 by the starting, at the starting itself we say that omega cube equal to 1, and 1 plus omega square is 0. That can be written as omega plus omega square equal to minus 1. Let's write it. Omega cube equal to 1, and as we see that omega plus omega square is minus 1 plus 1 as it is. So x square plus x plus 1. Therefore, we see that x squared plus x plus 1 is a of x to the power 5 plus x to the power 4 plus 1. Let's factorize it now. So we want to factorize x to the power 5 plus x to the power 4 plus 1. We know that x squared plus x plus 1 is a factor. So x to the power 5 can be written as x cubed into x squared plus x to the power 4 plus 1 as it is. Now, okay, that's equal to this. Now x squared, we will just write it as x squared plus x plus 1. But we want the equality, so I have to subtract minus x cubed into x plus 1. Rest of the expression as it is. X to the power 4 plus 1 as it is. So we see that we got, we don't see. We see that x squared plus x plus 1 is a factor of this expression. What about this one? X to the power 4 gets cancelled. Minus x to the power 4 minus x cubed plus x to the power 4 plus 1. X to the power 4 gets cancelled. Oh yeah, we can see that x squared plus x plus 1 is a factor. X squared plus x plus 1, because minus x cubed plus 1 cube, that can be written as we have a formula of a cube minus b cube. So 1 cube minus x cube. Let's do that. A cube minus b cube. 1 cube minus x cube is 1 minus x, a minus b, into a square plus ab plus b square. Well done. You see that x squared plus x plus 1 is a factor. Let's take common. X squared plus x plus 1, we take it common, and we are left out with x cubed minus x plus 1. Can we factorize this further? So we have obtained factors of a to the power 5 plus a to the power 4 plus 1 is x squared plus, a squared plus a plus 1 whole thing into a cube minus a plus 1. Can we factorize this expression?